So we're starting with modules 1 to 4. Basically, what we are trying to consider everybody, particularly those who are just starting out in IT, those who have limited experience. We don't want to assume that everybody has maybe a professional level of experience in IT. Right, so we're trying to make sure that everybody, regardless of the level where you are at, you are able to follow what we have for you in the course of this program. All right, so the training has been broken down into different modules. So we have modules 1 to 4, which basically will cover the basics of information technology, the DevOps philosophy, and then we move on to Linux, and then onto Git. All right, so we move forward like that, and then the modules 1 to 4 is expected to cover, the whole of June. We use June to cover all of that. We understand people have questions and all that. So whatever questions that you have, you can note it down in the course of the, maybe after each of the sections, we'll answer whatever questions that you may have. So please, I want to appeal to those of us who probably, some of us are professionals already. We just want to take the course to upskill or to just gain some more insight. We ask that you be patient with us, so that we can bring everybody on board. All right. So a few class information that would like to share with us. Somebody actually suggested, this a few stuff with me on the WhatsApp page, and I appreciate that. All right, so the class is going to be broken down into 2 sessions. All right, so each of the section will take about an hour for each of the sections, so that people don't get tired, all right, of each of the, if it's too long, because initially what I was thinking was maybe take the class for 2 hours, and then after that, people can ask their questions. But then somebody came up with a suggestion, and I think it makes a lot of sense. So we're going to have 2 sessions, so that will last 1 hour each. Right, at the end of each of the sections, if you have any questions, you can note it down and ask your questions. And that's the reason why for now I've disabled the chat and the Q&A section, so that people don't avoid any kind of distractions. Right, so if you have any questions as we go on in the course of the class, you can note it down somewhere, and then after each of the sections we take questions, we attend to it, and then we move on like that. Okay, so there'll be 10 minutes break at the end of each of the sections, so that people who want to relax or do other things can go ahead and do that. And then questions would be entertained. Oh, sorry, that's a typo there. Questions would be entertained at the end of each section. All right, so that means each of the sections will be recorded separately, and so we'll end up having 2 videos. So there'll be part A and part B for each of the classes that we're gonna have. All right, so let's dive into what we have for today. Let's dive into it. So information communication technology, like I said, we're starting from the very basics. We're trying to bring everybody on board. So for those that have some professional experience, please do bear with us. You can take this as a refresher class, all right, and then just follow along. Okay. So we're trying to make sure that at least people can follow whatever it is that we have for them. And so we're not going to be starting from with the big stuff. So we start from the basics, so that everybody can follow along, including those who are new to this field. All right, so information and communication technology, right? It's something that we've all heard about. It's something that it's a part of our life, right? Our day-to-day activity in our homes, everywhere. There's IT one way or another. All right, we interact with it, we use it, mobile phones and everything. But before the advent of information and communication technology, let's look at how human beings were interacting, right? So if somebody wants to send a message to another person, how were they doing it? If somebody needed to go to a place, maybe to travel and all that, how was it happening back then? All right, now for some of us who are maybe lovers of movies, maybe like adventure movies and all that, I'm sure some people have watched, there's this interesting movie that I loved. I think it took them about 10 years to even finish the whole movie. That's Game of Thrones, right? So if you watch the movie Game of Thrones, it's a wonderful story, right? So you will discover that in the course of that, you will see the way they were sending messages. Apparently, in those days, right, they were sending messages via ravens. So they would write a paper, write their notes, and then tie it together, put it in the leg of the raven, send the raven out, and then somehow the raven just knew, all right, where to go, all right, and deliver the message. So that was their own form of information and communication technology, right? So the information, they wrapped it around, and then put it, maybe between the legs or between the legs of the raven, and then the raven was, will help them to transport, all right, that information. So that was the technology, all right, at that time. And so, years went by, some people came up with better ideas, and then you had the, days of EDVAC computers, and all those kind of stuff, right? So the thing progressed, until we got to where we are today. Right now, today, you don't need to send many messages through Raven, all right? WhatsApp, you have Telegram, you have text messages, you have a whole lot, all right, ways by which you can, send messages across. Now, another example is, in those days too, you have the post office, right? So if you want to send a message to somebody maybe abroad or to another state, you can use the post office, all right? So they take your message, and then they take the address where the message is going, the postcode and all those things, all right? They package into an envelope, and then they send it. Now, the post office was an improvement, right, on, sending information through Raven and all that. But also that one also had some limitations, right? So because if you send your message through post office, there's no way to track, right? There's no way to get a feedback from the person or the organization that you sent the message to. All right. So that also had its own limitations because you only sent it. So what you would do then is that you have to go to the post office regularly to check, oh, okay, do I have any response from this organization, or do I have any response from this person? So you keep checking until you get there one day and they tell you, oh, okay, I think we have a message from you from that company, and then, oh, suddenly you feel a sigh, you feel relieved that, okay, finally this person has gotten, all right, my message. Now, like I said, that was an improvement on the Raven, sending out your messages through Raven. That also came by, but that also had its own limitation. Now we're at a stage, in our world now that, you have Gmail, you have Yahoo Mail, you have, all this kind of, email platforms, right? That you can use to send out messages, and you can get response from the people like almost immediately. If the person is online, they can easily reply your messages, and then you get your feedback. And then we have also, if you want to apply to an organization, you don't need to write a paper application and send it to the post office anymore. All you need to do is just to go online, type in the company's address, all right, create an application, send it down, the HR gets a notification, and like that, they treat your file, they send you a message, you get, it's becoming more easier every day. All right. And then AI is also trying to, they're also trying to use that to simplify the process even much better. So information and communication technology is just, basically all that I have explained, a way by which, people can communicate faster, better, all right, using means that are, all right, effective, and, all of that. So let's move forward a bit. Now, this information and communication technology that we talked about, all right, did not just come to be like that. It started somewhere, all right? It started, someplace. And where it started led, organizations then to, it actually started with the US Department of Defense, all right, the DoD, as they call it then, the DoD. So they wanted to, communicate among the different, department ministries and all that. So they found out that, oh, we needed to develop something. We needed to come up with an idea that can ensure that, somebody who is, let's say, somebody who is in this side, all right, of, the country, all right, I can send a message to them. If somebody is on the west side and then I am on the east side, there should be a way for me to send my message across. All right. So information technology, yes, we're enjoying it today, but it started from somewhere. So like I said, the US Department of Defense, all right, they are the one who pioneered, all right, that idea. And they came up with a model, right, which is called the 7 layers of the OSI model. The 7 layers of the OSI model. Now, one of the reasons why this model is important is because now when organizations started building out computers, right? When they started building out computers, they had a problem. Now, the problem was a computer manufactured by, let's say, HP, for example, could not communicate with another computer manufactured by Dell. So there was that, that communication issue, all right? Both systems, they cannot interoperate. Okay, so which means if you have a company at that time, that means if you're buying a system, at that time, you have to make sure that all the systems you have are from the same organization, from the same manufacturer, practically. All right. So in order for that issue to be corrected, now, all right, so we've created a system. We now have a system. We can send out mails. There's information communication technology, but then the systems cannot interoperate if they are from different manufacturers. All right. So they came up with the concept of OSI model. Now, what the OSI model basically does is to provide a framework that every computer manufacturer should follow in order to ensure that their product can interact with other products. Okay, so they came up with that 7 layers, all right, of the OSI model to say if you are developing a system, so whether you are Dell, whether you are HP, whether you are Asus, whether you are, Compaq, whether you are Lenovo, whichever manufacturer that you are, you must follow these layers in order to build, all right, the hardware of your system, so that anybody who has a Dell laptop should be able to communicate with somebody who has, all right, an HP system. So they came up with that layer. Now, quickly, let's examine the OSI, all right, layer. So there are 7 layers. Now, if you start from the bottom, of course, which is where you're going to start from, that's the physical layer. All right, the physical layer. And it tells us here, it says the physical layer transmits raw bit streams over the physical medium. Now, what is the physical layer? Now, right now, I'm sure most of us, I'm sure at least most of us are connecting, all right, to this meeting, all right, your system that you're using, whether you're using your tab or your laptop or your, maybe your phone even, right? I'm sure you're connected via Wi-Fi, right? So there's the Wi-Fi connection will be your home, so you're just seated on the couch, and then you're connected to the meeting. Right now, that Wi-Fi that you're using to communicate is the physical medium. Okay, because before you can communicate, right, with your system, before you can chat, okay, before you can pick up your phone and chat with somebody and say, oh, hello, how are you? How are you doing? And all that, your phone or your system has to first be connected, all right, to a physical medium. So that physical medium, if it's in an office, it can be a LAN connection, all right. If it's at home, it can be a Wi-Fi medium, all right. But the idea is before communication can take place, whatever device that you're using must be connected to a medium. That's the number one thing, right? So you can imagine if you want to send a message to somebody on WhatsApp and the data on your phone is not on, right? Even if you type the message on WhatsApp, right, and then you send it, okay, it shows that it will go, but then you have the mark, right? The check mark will not appear until your data comes on. Now, when the data comes on, the check mark appears, all right? Now, the check mark appears once, that means the message has been sent. Now, the other person on the other side, if the person is not also connected to any physical medium, maybe a Wi-Fi or a LAN or something, right, the person will not also receive the message. So the person on the other end also has to turn on, all right, their own data, right, in order for them to receive that message. So that's the first layer, the physical layer that guides data communication. Now we move on to the second layer. All right, now you are connected to the physical medium, all right, and then now we have what you call the data link layer. Now, the data link layer basically is that every system, whether mobile phones, whether a laptop, any computer at all, right, has what you call a MAC address, all right, a MAC address. Now, what does the MAC address mean? The MAC there means media access control, all right, media access control. That's what the MAC address means, all right. Now, the MAC address, it's an idea, right, that, of course, the people who pioneered this model is an idea that they came up with to ensure that every system that is produced by any computer manufacturer comes with a unique MAC address system. All right? There are no two systems in the world, that has the same media access control number. All right? There are no two systems. So at that layer, your system has a MAC address. Now, even your mobile phone has a MAC address. For example, if you're using your phone, if you go to maybe your Wi-Fi section and all that, and you go and check your settings and things like that, you're going to see an IP address, and then you're going to see a MAC address. Now, the MAC address is actually written in it's an hexadecimal format. All right, so you have things like OHAB and all of that, stuff there. So the data link layer, it says defines the format of data on the network. So there's the MAC address at that layer, all right, and then And that's where, you know, all your switches and all those things are connected to. Okay. So, but just understand that the data link layer is the layer, all right, that controls some kind of data on the network. Now you have the third layer. Now, the third layer is where most of us, you know, we are operating in, right, which is the network layer, right? Every system must be connected to a network, and then that network must be able to understand, all right, how to route your traffic. Okay, that sounds somehow. So what does that mean, right? If you look at what it has there, it says decide which physical part the data will take. Physical part which the data will take. So how do we explain this? Now, if you have your phone or your system connected, all right, in your office, for example, you know, some of us, I'm sure some of us work in an office and all that. Now, there are some office where if you're on the office computer, right, you don't have access to Facebook or any other site aside the company's, all right, internal software. For example, those that work in banking, for example, the moment you sit down, you sign in onto your system, the only access you have is what? Is the software that is being used in the organization. You don't have any other access. Okay. Now, if you try to access any other site apart from the site that the bank has allowed, which is, you know, technically their own, all right, website, you get errors, right? The system will tell you, oh, for maybe for error not found or something like that. You get, you know, you get some kind of errors because the organizations that they put measures in place such that you can only access, all right, the organizational, you know, website within that network, all right? So which means whatever part that your system needs in order for that system to access the internet has been blocked. So if you go to any software or any kind of website outside of that organization, all right, at that network layer, your system does not know how to connect to the outside world because the network guys in the organizations, right, they have blocked that access. All right, they have blocked that access. So you cannot access any other site. So at that third layer, all right, the network layer, it decides which physical part the data will take. Okay, so if you want to do some kind of browsing, if it is allowed, yes, your system sees the request and then does the necessary stuff at that layer. All right. Now, all of these layers that we have here, okay, now they are connected one way or another, right? Because if you look at it, before you can even talk about the network layer, all right, before you can even talk about accessing Facebook or Yahoo or YouTube and all of that, the first thing that your system has to be connected first, which is the physical layer. All right. So without the physical layer, there's no network layer, because if your system is not connected, of course, you can't browse anything, you can't check any website, you can't go to any place, you can only play games on your phone. All right. But then the physical layer is the first thing. So your system has to be connected first of all right, before we can talk about moving on to the other layers. So at the network layer, that is the layer that determines, all right, which physical parts your data will follow. Now, the transport layer, all right. Now, for every application that you have on the internet today, right? For every application you have on the internet today, there is what you call the transport, all right, transmission protocol. Now, what does that transmission protocol mean? Now, we have so many applications in the world today. You have voice applications, all right, like WhatsApp, for example. You can use it for texting, you can use it for calling and all of that. Telegram and all those stuff. You have so many applications. All right. Now, how, you know, once you are connected at the physical layer, all right, and then your network layer knows what part the data should take, the question now is, how is this data transmitted? All right. If I go to yahoo.com, for example, how does the traffic move? All right, to the point where I can now see a page that they write Yahoo, and then I can sign into my Yahoo mail account, and then I can do whatever that I want to do. Now, all of that transportation, okay, happens at the fourth layer, which is the transport layer. That's where the transmission protocols are defined. Now, what are transmission protocols? Now, they have divided these protocols into 2. All right, you have the TCP and you have the UDP. All right, the TCP, and the UDP. The TCP is Transmission Control Protocol. The UDP is User Datagram Protocol, right? Now, what does this thing mean? Now, let's look at it like this. Let's look at an example. For example, now one of the things about this thing is one protocol is reliable, the other one is not reliable. Okay. Now the TCP ensures that your data, all right, whatever request that you have made, all right, it ensures that that request, all right, gets to where it needs to get to, and then it ensures that that delivery is okay, 100%. Now the UDP on the other hand, it doesn't care. If you send it out and it gets there, good. If it doesn't get to where it's going, it doesn't even bother about it. Now let's look at the TCP and the UDP in this manner. For example, let's use a travel company, for example. Maybe you want to send out something to somebody, and then you want to use, you need somebody to help you to do the delivery. Now, TCP, let's consider TCP as DHL, right? Now you go to DHL will take whatever it is that you want to send. They take the address and all that, they weigh it, they give you a receipt, and then they give you some kind of ID that you can use to track, all right, that item that you have sent, all right, ensuring that at every stage you can track the delivery of that item. Now that is what TCP does basically. All right, so with TCP you can track, all right, you can know if this thing is gone, if it is delivered, if it is not delivered. You can get all of those details. Now with UDP, all right, that connection is not guaranteed. Okay. Now, what is an example of a UDP? Now, we said the UDP is User Datagram Protocol. Now, there are cases where sometimes if you make a call to somebody, maybe a WhatsApp call or something, all right, and then at some point in the middle of that call, all right, the voice starts breaking out, and then you can't hear the person clearly, and then you start saying, "Oh, hello, 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 can you hear me?" And then you call the call, you call the person back. Now, what just happened, all right, because your voice application uses the UDP, all right, so connections are not guaranteed, okay? The delivery is not guaranteed, all right? And that's why you have those breakage, all right? You are calling somebody, the calling is breaking, and sometimes, sometimes for some of us, for some people, who have experienced this before, sometimes you send a message to somebody, maybe like a text message or something like that, and then the message will come in, but then the person will not get the whole message, all right? It's just going to be maybe half, and then after some time, the remaining half comes in. Okay, so at the transport layer, it just basically defines, all right, how your data is moved, all right, from your own end to the other end. Okay, so you have the TCP, you have the UDP. Now, all the protocols you have in the world, right, they fall into these two categories. There are some protocols that are UDP, there are some protocols that are TCP. For example, your web traffic, which is the HTTP, right, all the website that you visit. Now, your websites, all the websites that you visit, HTTPS, they fall under the TCP because, all right, websites, HTTP and all that, they need to guarantee, connection and all those kind of things. So everything that you do online, your email address, your email, all the softwares that you use and everything, they are partitioned into these two transmission protocols. So how does this, all right, this particular application, how does it carry message? So they break it down. This one is TCP and this one is UDP. Now we move up again to the section layer. Basically, what that one does is to maintain connection and is responsible for controlling ports and sections, right? Now, for every application that you have, all right, that we use on the internet, the web applications, the software applications, whether Office 365, whether Dropbox, all right, whatever application that you use, okay, these applications need to maintain sections. So this application, they have the protocol that they use and they have the port numbers that they use. Now, going back to the post office address or the post office example, now, each of those applications, right, that we use, look at the post office, for example, when you're sending the package to somebody, there's an address and there's the postcode. Now, that address that you have on that, right, package can be termed as the protocol. The postcode is the port number. All right, look at it that way. The address on the package is the protocol that is being used. The postcode all right, that is attached to that address is the port number. All right. So for some of us who have been in IT, you're right, you hear, oh, HTTP is using port 80. HTTP is the protocol, but the port it uses is port 80. Oh, you hear things like, oh, SMTP is port this and all that. You know, you hear different kind of protocols. So we're going to look at those things shortly. So at the section layer, that one is responsible for managing those sections. All right, making sure that, you know, once you are connected to that site, you stay connected. Like, for example, this meeting we are having, we're using Zoom, for example, and then something is ensuring that this connection remains, that, you know, people are able to hear what I'm saying, all right? You are able to view my screen and all of that. And then you move on to the presentation layer, so which ensures that, you know, that data that you have requested on the internet, that website that you have gone, you are able to see all that is, you know, available on that website in a legible, all right, in human readable format. That's the job of the presentation layer. Okay, so that if there's any text on that particular website, you're able to see the text clearly. All right, everything is designed as it should be. All right, and all of that. So, and then the last one is the application layer, which is the human-computer interaction layer, where applications can access the network services. All right, where applications can access the network services. So at the application layer, that's where you now have all those protocols, right? The HTTP, the HTTPS, SMTP, and all those protocols, as we're going to see shortly. So if you move up, so look at the data communication protocols. So now at the physical layer, you have your Bluetooth, your Ethernet, and your Wi-Fi, like I mentioned. At the data link layer, you have all of those protocols, right? For some of us who you know, maybe being in IT for a while, you discover that you have a few protocols that looks familiar here. For example, CDP is a familiar protocol. STP, spanning tree, for those that are into networking and all that, you know what STP and CDP is about and all that. So those are just some of the protocols that exist at these different layers. Now, at the network layer, where we talked about earlier, which we said, you know, is the layer that is responsible for the paths, right? How the request you have made moves from point A to point B. So you have other protocols, and one of the protocols that we're going to be looking at in the course of the class is the IP version 4. All right, IP addressing. All right, what is IP addressing? How do we assign IP addresses to our systems and all of that? And then the transport layer, like I said, you have the TCP and the UDP. One is reliable, one is not reliable. Like I said, the TCP is just like just like DHL. All right, your delivery is guaranteed. Okay, if you use DHL, if you use others popular delivery companies, Amazon delivery and all that, your delivery is guaranteed. If there are any issues, they have a way to refund you. They have a way to make sure that you don't lose anything and all of that. So that is TCP. So your connection, your communication, everything is guaranteed. On the other hand, your UDP is not guaranteed. All right, and that's why if you can't hear somebody clearly on the phone, maybe there's some kind of breakouts and all that, you will discover that what that person said is not replayed back to you. All right. If you didn't hear what the person said, it's gone. The person may have to repeat, all right, him or herself for you to get what they are trying to say. But all those, times that they were trying to say something and you couldn't hear what they were saying, okay, those things that they were saying, you won't get it back. It's not going to be replayed back to you. All right, that's UDP because it's not reliable. All right, unlike TCP that ensures that even the packet that gets lost, it tries to do what? It tries to retransmit, but UDP doesn't retransmit. And that's why you cut the call, you call back again, and then after some time again, you can't hear what the person is saying. The person is trying to talk, you can't hear what they are saying. All those things they were trying to say, you won't get it back again because that communication is not guaranteed. And then you have the session layer, you have the presentation layer here, and then the application layer. So you have your DNS, your FTP, which is your file transfer protocol, how you send files from one system to another, sharing files with people and all of that. You have your HTTPS, which is, all right, the browser that we use. You go to a different site every day, that's HTTPS. You send mails as well. So your POP3 is used for mails, your SMTP is used for emails, right? The Gmail that you use, these are the protocols that they use. Gmail, Yahoo, others, they use the same protocol. Okay, and that's the job of the OSI model, to ensure that every system is built using a particular model, right? So if you have any questions, just note it down. After this first session, we'll take all those questions. So now let's look at protocols and port numbers. Now, this thing is very important because going forward is going to help us because we're going to be talking a lot about, we're not going to, we'll get to a level where we will not be able to say, HTTP, and we just say, oh, okay, have you done this? Have you done that? Okay, port 80, port this, port that. So we need to get familiar with all these port numbers so that when you hear a port number, you can easily map it to a protocol. All right, like I said, the post office example again, the address you have on that package, it's your protocol. The postcode is what is your port number. All right, now let's look at this protocol. Now you have the file transfer protocol, and the port number that it uses is port 20 and 21. Now, all these protocols and port numbers that you have is something that's defined by an organization called ITU, International Telecommunication Unit. And then they have these meetings where they come up with all these policies and protocols. And in that meeting, they have a document that they refer to as RFC. All right, RFC. What does RFC mean? RFC means request for comment, right? Request for comment. So that, in case you're just wondering, okay, so how did they come about all these numbers and protocols and names and all that? All right, there's an organization, like I said, International Telecommunication Unit, ITU. All right, so that organization is responsible for all the protocols and port numbers that you have today that is driving, all right, whatever we see on the internet. Okay, and so within that RFC, that's where they now define, all of those protocols and port numbers. Okay, RFC, request for comment. So they have a meeting, they come together, different professionals from different fields, people from Microsoft, people from different organizations. They come together, they brainstorm. And then they tell us, oh, okay, the next thing now is we have a new protocol. This is going to be the port numbers and all of that. Okay, so the first one here is file transfer protocols, which runs on port 20 and 21. You have the SSH protocol. The SSH protocol is used to log in. For example, if you're using Linux, we're going to be using Linux. All right, in the course of the class, we're going to be setting up a Linux server. You're going to be interacting with the Linux server. So you need to know that your Linux server, in order for you to log in, to access the Linux server, you need the SSH protocol. All right, and the SSH protocol, all right, works on port 22. That's the protocol it uses. Now, there's a protocol that is similar to the SSH, which is the Telnet protocol, right? That one uses port 23. Now, SSH and Telnet, they do the same thing in the sense that they allow you to log in into systems that do not provide you with graphical user interface, all right? Now, this system that I'm using now is a Windows system, all right? It provides me with a graphical user interface, right? So I can, there are icons, there are menus and all of that I can press. But when you're using an SSH, for example, when you're logging into a Linux system, all right, and Ubuntu, Debian, and all those versions of Linux, Red Hat, and the rest of them, you SSH into them because most of the servers that you use in production environment, in a real world environment, they are Linux servers, and most of them, majority of them, do not come with a graphical user interface. All right, there are no icons to click, there are no buttons to press. All right, it's just a black, interface with a prompt. Okay, and then you start typing your commands in that prompt. Okay, so your Telnet and your SSH gives you the privilege to log in into the system. Now, the difference between the SSH and the Telnet is that one is secure and one is not secure. The SSH, like the name implies, is secure shell. Now, the security in this sense is that anything you do within your SSH terminal, right, that is being transmitted within that terminal, even if somebody intercepts your traffic, maybe there's a man in the middle that's trying to watch your traffic and trying to capture your packets and all that, they are not able to decode whatever it is that you're doing. All right, so which means even if you are typing out a password and all that, on the system, they are not able to still decode, all right, your system. Okay, so that's the SSH. Now, the Telnet, on the other hand, whatever that you do within that environment, within that, terminal environment using Telnet, everything is in plain text. So which means people can view it, they can see it. All right, so it's not something that is being used, anymore, all right, in any production environment. Now, the next one is your simple mail transfer protocol. Now, every email that you send, there's the outgoing email, all right, and there's the incoming email. If you send message to somebody, that is outgoing. Now, something is responsible for that outgoing email that you're sending. right? If you receive a mail from someone, that is an incoming mail. Something is responsible for that incoming email, right? Your SMTP is responsible for your outgoing email. So every email you send on Gmail, on Outlook, on Yahoo, right, uses the SMTP protocol. That's the protocol it uses, all right, for all the emails that you've been sending. That's the protocol it uses. Okay, so that's the incoming, the outgoing email. That's the protocol it uses. Now let's move on to DNS. Now, domain name system. Domain name system. Now, how did we come about this name, or how did they come about this domain name system stuff? Right now, initially, computers only understood zeros and ones, right? So when there's Web 1.0, there's Web 2.0, so people had to develop a website. And so those websites, if you want to access them, you may have to access them through IP address, right? Now, every website that you have in the world today has an IP address that is connected to whatever server that website is hosted upon. But it does not make any sense, because it would be practically impossible to tell people to memorize, all right, IP address. Now, you can imagine if you want to go to Gmail, and then if you want to go to Gmail on your browser, and then you have to memorize, let's say 192.168.10.0 to access Gmail. That would be, you might forget, okay? Because it's not everybody that is good with numbers. So they came up with an idea that why not come up with a system that can help us to map this IP address to a particular name, so that name is easy for people to remember, all right? For example, Netflix.com is easy to remember. Oh, Netflix.com is easy. Just start going there, Netflix.com, and then you have access to Netflix. Oh, Gmail.com, that's easy to remember. Now, all those names that you have, they are what you refer to as a domain name system. Now, behind that name, there's an IP address, because that website that you're accessing is hosted on a particular system, just like the system that you're using. It's just that in this case, that system is more powerful, in the sense that the system has more processor, all right, power. It has more memory power. There's a lot of storage on that system, all right, compared to the one that you and I we use in our homes, right? But whatever website that you visit, gmail.com, amazon.com, all those websites, they are hosted on a particular system. And that system has an IP address. But in order for them not to give their customers any trouble and all that, okay, they came up with a domain name system to say, let us map this IP address to a name. So each time people go to amazon.com, right, that name resolves back to an IP address. Now, let me show us something, at least, like I said, for the benefit of those who may not, right, they are new to all of this. So, for example, let me say, if I want to check the IP address of amazon.com, right, all I need to do is to say ping amazon.com. Now, watch what happens. Now, what happened? That name, right, my system took that name, and my DNS server resolved it to the IP address of Amazon. So, which means amazon.com is hosted on a server with this IP address, 54.239.28.85. Now, you can imagine if you want to go to amazon.com and you have to use this IP address, you may forget. All right. So that means if you want to go to amazon.com with an IP address, you have to note it down. So anytime you want to go to amazon.com, you have to open your notepad and then check the IP address to make sure you are typing the correct thing. Okay. So that becomes a lot of issues, right? Because not everybody will be able to remember that. You can imagine the amount of IPs you will have to memorize. So for Amazon, you memorize the IP. For Netflix, you memorize the IP. For Zoom, for Gmail, for Yahoo, you memorize the IP. For Outlook, you memorize the IP. At the end of the day, you're going to forget. But it's easy to just say, oh, I want to go to my outlook.com. That's easy to remember. Oh, I want to go to Netflix.com. It's easy to remember. Even if you forget, you can go to Google and just type Netflix, and then you get the site, and then you can go to the website that you're going to. All right. So the DNS came about as a result of this to say, you know what? Let us have a system, all right, that we can use to create a name. And then that name, we're going to put that name on top of an IP address, all right, so that each time people go to that name, all right, the system, all right, following the OSI model that has been developed, resource that name back to an IP address. So if I say ping, gmail.com, for example, it gives me the IP address of Gmail. So that's the IP address of Gmail. If I say ping, netflix.com, it resolves again. So netflix.com has an IP address of 18.200.8.190. Okay, so that is what the DNS is all about. Okay, resolving host names to what? To IP address. And then again, you have another protocol, dynamic host control protocol. That is what is responsible for automatically giving your system an IP address. So if you put on your data on your mobile phone, you automatically get an IP address from your service provider. So DHCP is responsible for that operation. Now, the popular HTTP, Hypertext Transfer Protocol, that is responsible for all the website that you have in the world, right? All the website uses HTTP. YouTube, name it, any website uses HTTP. But then HTTP also has two versions. So there's the one that is secure and there's the one that is not secure, right? The HTTP, which uses port 80, is not secured, all right? So which means that website may be prone to hackers, right? People can hack into that site, they can steal some information and things like that. So that's responsible for that. Now, the next one here is post office protocol. I mentioned earlier, I said, when you want to send out an email, all right, to anybody, you use the SMTP protocol, all right, which uses the port 25 as the port number. Now, when you want to receive an email, you use what you call the post office protocol. You can see that they have to tie it towards the post office idea, right? Because if you send out something via your post office, that can be referred to as SMTP. When somebody sends you an email via your post office, that can be referred to as an incoming email. So they have the post office protocol, so POP3. All right. Now, there are several protocols for receiving emails when it comes to Gmail, Yahoo, Outlook, and all those mail providers, right? There are two ways. Now you can use the POP3, or you can use what you call the Internet Message Access Protocol, IMAP4. Now the difference between the two is that one of these incoming email protocol allows you or gives you the functionality such that, for example, if you have your mail configured on your mobile phone, and then you have the normal web access to your email, like gmail.com, you go there, you check your email. Now, what one of them does, I can't remember the exact one, but I think it's IMAP. Now, IMAP gives you this kind of functionality such that if I delete a mail, all right, on my mobile phone, so if I have the Gmail application on my mobile phone, and I delete a particular mail, or I read, all right, an incoming email on my mobile phone, automatically, if I go to the Gmail website to access my mail, that email will be shown as read already. All right, that's the difference between the POP3 and the IMAP. Okay, so which means one of them, anything you do on your mobile phone or anywhere, if you go to another place where you have your email configured, the what you have done on one, all right, on one of the platforms or maybe on one of your system automatically reflects on the other. Okay, so that's just the difference between the two. Meanwhile, the other one retains those information. So even if I read my email on my phone, if I go to the web, I will still find it as unread. Okay, that's just the difference between the two. So those are the two protocols that you can use to receive emails. So POP3 and IMAP. Then there's the NetBIOS service name. That is for those, I think, for Active Directory and stuff like that. So let's not go so that we'll not confuse people unnecessarily. And then, so the secure version of HTTP, now you now have what you call the HTTPS, all right? The HTTPS, all right? That's the secured version. Okay, now if you look at all these websites, they have the HTTPS right here, all right? So if you click here, if you click on this icon, it tells you that your connection to this site is secured, okay? So if you look at it, it tells you that this site has a certificate, and then any information on this site is secure. So that's the difference between the two. Meanwhile, for HTTP, it's not secure, so people can hack into your website. And then last one, we have the Microsoft Active Directory protocol as well. All right, it's almost 1 hour. So let's look at a few stuff before we pause for this session. Now, for every website that you visit, like I said, it uses the HTTP protocol. And there are popular, status codes, all right, for HTTP. Now, all the status codes, sometimes, as simple as they may seem, there are things that come up during interviews, right? Because in an interview, most times they don't even ask you to add stuff. It's just basic stuff that they ask. And so what most people tend to do is they prepare for the add stuff, like, Kubernetes, they prepare for all those, high level stuff. But most times in an interview, they ask you some of the basics, right? Just basic things. You just want to check, okay, are you really grounded in this thing? So they ask you some of the basic things. So these status codes are things that they can ask you, all right, during an interview, right? They can ask you, oh, okay, so if you encounter a 400 error on a website, what does it mean? And then they expect you to tell them, oh, 400 errors are in levels. There's 401, there's 403, there's 404, there's 405. All right, all these things, they have what they mean. All right, so let's go through them, all right, one after the other, because I'm sure one way or another, most of us have encountered an error. Maybe you were trying to access the site and then you see 404 error, or you're trying to access site and you see 504 error. I'm sure at one point or another, in the course of, using the internet, you must have encountered one of these errors, all right? Now, the first one is, all right, the 100 error, which is the informational code. It says the server acknowledges and is processing the request. And then there's the 200, which is success code. So anytime you won't even see 200, what you are just going to see is the page. So if you go to a website and you're able to access that website successfully, what just happened is that, the 200, kind of stuff, all right, just out, so which means everything is okay, the server is accessible, there are no issues, everything is running as expected. Now there's the 300 errors. Now the 300 errors is in 3 levels. So you have the 301, right? I hope you're noting it down. You have the 302 and you have the 304. Now the 301 is, an error that says something has been permanently redirected, okay? So it's not, so when you encounter a 300 kind of error, it's not something that, it doesn't mean that something is wrong with your own system. It just means that on that particular website that you're trying to access, or on the server that you're trying to access, all right, there are some operations that are ongoing. It says the server received your request, but there's a redirect to somewhere else and all of that. So which means your system is fine, your internet connection is okay. It's just the site that you're trying to access. And then there's the 302 error, which is a temporary redirect. And then there's the 304, which is, something that has not been modified, something not changed. Now, the important ones here are the 400, type, and then the 500, all right? The 400 and the 500. Now, the 400 is client error codes, all right? So which means the client error means that you are the one that is doing something wrong, all right? You are the one that is not doing something correctly, all right? That's what the 400 error simplifies. It says the server couldn't find or reach the page or website, and that is an error on the site side. All right, so the 400 error says client error codes. Now you have 4, all right, of these 400 codes. So you have the 401 error, you have the 403 error, you have the 404 error, and you have the 405. Now the 401 means unauthorized error. All right, unauthorized means you don't have access so that you don't have the required permission to access what you are trying to access. All right, that is just basically the 401 error. Now the 403 is forbidden. So which means what you are trying to access is not publicly available. All right, so it is forbidden from public view. So that means what you are trying to access is available on the server. It's just that it has not been made public, so anybody cannot view it. Okay, so which means it's not that you have made a mistake, but then it's just that that particular thing you're trying to access is not for public consumption. All right, and then there's the 404 error, which is popular. The 404 error means not found. That's what that means, not found. So which means what you are trying to request on the server is not available on that server. So you can see the difference, right? 401 unauthorized, so you don't have the required permission to access it. 403 forbidden, what you are trying to seek on the server is not for public consumption, all right? It's available, but you cannot access, it's not being made public. Now there's the 404, which is not found. So which means that particular thing you're requesting is not available on this server at all. All right, maybe you should try another, all right, or another URL. Now, the 405 error, which is the last one, is method not allowed. All right, method not allowed. What does that mean? You're trying to use, maybe you're trying to access something in a particular, because everything on the internet follows a particular order. There are protocol that guides our communication. There are protocol that guides what we do. Okay. For example, if I type in HTSP and then I want to access a website using HTSP, all right, that's a method that is not allowed. That's a method that's not been defined. All right, it's not a method that has been defined that I can use to access anything on the internet, right? So that's a form of method not allowed. So you're using a method that is alien, all right, to that system. That's what the 405 means. Now let's move to the 500 error. So that one is server-side error, so which means practically something going on the server side of things, all right, which you do not have any control over. All right, now there are also four 500 error codes. So there's the 501. 501 means this thing is not implemented. So if you look at what we have, it says the client made a valid request, but the server failed to complete the request. That's the summary of the 500 error. So there are four, all right, types of this 500 error. So the first one is 501, which means not implemented. So what you're looking for is not implemented on the server. All right, so maybe you're trying to check a website using some kind of parameters, and such parameters are not implemented on the server, so you get a 501 error. There's the 502 error, which is bad gateway. All right, 502 error, which is what? Bad gateway. So technically what that means is that the server that you're trying to access does not have a kind of way to interpret, okay, what you're trying to access. All right, that server cannot interpret your request. So it throws you a 502 error and says bad gateway. Now there's 503 error, which says service unavailable. All right, so which means now that service unavailable 503 error means it's possible sometimes that the server may be overwhelmed. Maybe there are too many users on the system, and then so you can't access it at that time. So the service becomes unavailable. Or another thing that could happen is that maybe that particular service is the maintenance mode. Maybe they are working on it, they are doing something on it. So at that time, it's not available. So you get a 503 error. And so the last one there is what? The 504 error, gateway timeout. That happens a lot when a server is overloaded, when there are multiple people trying to access it at the same time. So you get a 504 error, gateway timed out. So if you get that kind of error, after some minutes, you refresh the page again, it gives you something that you're looking for. After some time, you refresh again, you get that error. So basically what that 504 error means is that there's so much, all right, traffic on the server right now that it can only respond to as much request as it can afford. All right, so that's just a rundown of the HTTP codes. All right, so we'll spend the first 1 hour. So let me enable the chat section so that people who may want to ask their questions can ask. All right, the chat is opened. Let me see the Q&A. All right, now, so if you have your questions, you can ask. I think we've completed the 1 hour already, so that if you have any questions, you can ask before we go ahead from here. We still have a few more information you want to give us. Now, all this information that we are providing is just basically for those who are new, all right, to IT, all right. We're just trying to provide some information so that as we go on, because as we go on from here, it becomes, all right, more hard, it becomes tense and all of that, so that if you're familiar with some of this concept, by the time we start talking about this and that, you already know what we are talking about, all right, so that we don't just assume that everybody knows this thing. Okay, so if you do have any questions, you can put it in the chat section. Now you can raise up your hand, you can drop your questions. The box is opened. All right, do we have any questions so far before we go ahead on a short break? Any questions? Now, we are here for the DevOps training, right? So there's no way we can skip the software development life cycle. Now, having said, all the things that we said before, we talked about the data communication, how it started, all right, the protocols that is being used and all of that. Now, for every software that has been developed, right, the software needs to run, right, on a system, all right? There has to be an infrastructure that would ensure that that software runs successfully. All right, and that's why network communication or data communication is important. And so whatever, whether you're a DevOps engineer or a software developer, you need to still understand data communication, because the application you're developing, if you're a software developer, for example, all right, needs, all right, you to use a particular protocol to run, and then you also must be familiar with those port numbers, which is why we had to explain all of those port numbers and protocols for us. So let's look at software development life cycle. Now, again, let's iterate here that as a DevOps engineer, all right, you are not an application developer. That is not your job. Your own job basically is to ensure that you provision the infrastructure that is necessary to run, all right, whatever application that is being developed within the organization and all of that. So your own job basically is to put the infrastructure in place that will automate all the processes of this software, the delivery and all of that. So that's what your role is. Now let's talk about software development lifecycle. What is this thing about? Now, if you look with me, there are 6 steps right here for the software development lifecycle. There's the planning phase. All right, there's the analysis phase, design, implementation, testing and integration, and maintenance. Now, in the early days of software development, let's try to provide some background here. All right, in the early days of software development, right, this was, what was guiding whatever software that people were developing. So there has to be planning. All right, you needed to plan. You needed to analyze, all right, analysis being all the requirements that you've gathered at the planning phase. You need to analyze those, requirements that you've gathered. You need to analyze what the customers say they want and all of that. And then after the analysis has been done, then you move on to the design phase. So basically you come up with an architecture, all right, of what you want to build. So that design phase, that's where your UI designers comes in, the user interface and the UX designers, that's where they come in, they put everything in terms of graphics and all that, so people can see, oh, at the end of the day, this is how the site is going to look like. So once the design has been done and then it's been approved by the, appropriate authorities and people that, have that mandate, then you move into implementation phase. So it means your programmers now, they start developing the application to achieve what has been designed. After it's been implemented, they come up with a code and all that. Then the code is tested, is integrated, all right, and then they move on to the maintenance phase. Now, your software development lifecycle has different models, all right? And if you look at this development lifecycle, you can relate this to when somebody is trying to build a house, right? Now, if you want to build a house your own self, let's assume, we're in an age, let's assume, in those days where, we don't have realtors, real estate is not a big business like it is today. In those days where you have to buy a land, do all the preparations yourself, search for the land in whatever area you want and all that. All right, that's just basically what a software development lifecycle is. So the planning is you looking for a land that you want to build something on top. The analysis is you carrying out survey on that land to discover, oh, is this land okay? I hope it's not a waterlogged area. Oh, I hope, okay, if I build, a 2-bedroom here, I hope there will not be problem. If I build a duplex, a studio, whatever it is, you do your analysis. Now, that analysis also involves, it can also involve people like, your quantity surveying, all right? I'm trying to relate this to just, somebody trying to build a house, right? The analysis can also involve, the quantity surveyors, right? They tell you, oh, this apartment that you want to build with this kind of idea that you have, you might need it. You might need like 10 bags of these. You might need this amount of wood. You might need this amount of block, this amount of brick, and all of that. The design phase is where you now bring in the architect and say, "Oh, architect, I have this idea in my head. Can you come up with something for me, design and all that?" Oh, the architect says, "Oh, of course, of course." So that goes to his drawing board. It draws out something for you, and maybe using softwares, different softwares, ArchiCAD and all those kind of stuff. Design the software, designs the apartment and all that, presents the apartment to you. And if you're okay with it, you say, "Oh, wow, I love this design and all that. I think I love this, the way you so let's build this." So the implementation phase, that's where you do the mobilization. Everybody comes to sites, they start building out according to the design, in this case, according to the architecture. And then from there, after the whole building has been done, if you have a lot of money, you can bring in maybe structural engineers and all that to test, to check, all right, to see if everything is done properly and all that. And then you move on to maintainer, you start maintaining, oh, this pipe is busted today, you maintain it and all that. So the same thing also happens with software development lifecycle. So you plan, you analyze, you design, you implement, and then you test, and then you maintain. But like I said, this development lifecycle has different models that you can work with. So let's look at the first one. So the first one is the popular waterfall model. Now, waterfall model was great because it was great. It was used for a long time. But the downside of the waterfall model and why it's no longer used today is because every step must be completed before you move on to the next step. All right, so which means you must finish gathering requirements before you can move to analysis. All right, before you can move to design, you must have done all your analysis. And then before you can start coding or start developing the application, you must have been done with design. So the waterfall models follows that pattern. So you have to complete one step before you take another step. And so that takes a lot of time. So you can imagine you can spend like 2-3 months on requirements, spend another 3 months on analysis, spend another 4 months on design. Before you know what is happening, it will take you like a year to come with an application. All right. So that was the downside of the waterfall model. All right, because it wasn't flexible. And then it takes a lot of time for people to release, applications and all of that. And so the agile model came, which is what the DevOps have actually adopted, the agile method. Now, the agile method is simple. It just says, you know what? Instead of waiting to gather requirements and all that, let's do something. Let's push it to the market. Let them test it. Let them give us their feedback. With the feedback that they provide us with, then we can now start modifying and start improving on the software, right? We don't have to wait until everything is perfect, like the waterfall model. The waterfall model, every step must be perfect before you go on to the next. All right. So the DevOps basically built on top of the agile methodology, which is you don't have to wait until everything is perfect. Like I said, you can come up with something. And that is why you will discover that in our world today, there are a lot of softwares that people are just developing. You go to Play Store today, there's this app for this, there's an app for this, there's an app. People are just coming up with different applications almost every day. All right. And that is why if you're using whatever mobile phone that you're using, whether Apple or Google or Android, all right, there's the Apple Store, there's the Play Store. For all these applications that you download, there's a place where you have reviews, right? So which means if you're a user and you've downloaded the application and you feel something is wrong, the application is not working according to your own expectation, you can write a review and tell them, oh, okay, I downloaded the app, it worked for a while, but after some time I discovered that if I press a particular menu, it shuts down. If I press this, it doesn't do this and all that. Now, the developer, they will go through all of those reviews, collect those informations, right? That is the client feedback that you have there. They take all those information, they take it back to the development team, they work on all those reviews, and then they update the application, and then they do what? They push it back, all right, to production. And then the next time you open your phone, all right, it tells you, oh, there's an update. You download the update again, you use it. Some other people also download the update and use it, and then there are reviews and say, oh, okay, the update was released, but then I discovered that after the update was released, this were not working as expected like before. They take all those reviews again, and then they go back and then they build. And that's why your DevOps is an iterative process. All right. It does not wait for every aspect or every step of the software. It doesn't wait until everything is fully developed or fully perfect. It just simply relies on customer feedback. All right, it relies on customer feedback, and that's why it's an iterative, all right, process. And that's why it is really very important. Now, let's talk about DevOps. Now, why is this DevOps thing becoming popular? All right, we've talked about the agile methodology, an iterative process. You don't have to wait until every step is perfect. All right, you simply package something, do something, send it out there, let people test, let them review, take their reviews, use that to build your application to make it better and all of that. All right, but now let's look at DevOps itself. Now, what is DevOps? All right, DevOps, is it tools? What exactly it is, is DevOps. Now, basically, DevOps is just basically a philosophy, a principle, or you can call it a concept, all right, of doing things. And what is that concept all about? The concept is about automation, basically, all right? So automation in the sense that we want to try as much as possible to automate every process, all right? Every process should be automated. Now, automation in this sense, does it mean that human beings will no longer be able to do anything? Does it mean that systems just have to do everything by itself? No. But what we are saying is that we want to try as much as possible to reduce human errors. Now, before DevOps came into being, all right, before it became something that was popular that everybody is now talking about DevOps. Now, in an organization, all right, if you're doing software development in an organization, of course, you have different teams. You have the developers that will build the code. You have the operations team that will maintain the server and all of that. All right, the developers, they package their codes. They send it to operations to say, operations, we're done with our code. Go take it and run it. And then let's have, people test it and all. So there's a lot of issues. Developer will say, oh, I've done the code. Everything is working on my end. The operations will say, well, I tried it, but I'm getting errors and all of that. Okay, so the DevOps principle was born to say, right, you know what, all these manual processes that you guys are doing, let's automate all those processes, right? So you take your code, commit it into a repository, all right, let the DevOps engineer set up a pipeline that will run this application, so that within that pipeline, there'll be testing and all of these things, so that it won't look as if maybe somebody on the team is trying to sabotage another person's effort, right? So we have systems in place that can check if what you've done is okay or not before it goes over to production. So at the end of the day, we are not going to blame anybody. So the system is going to test it for us and tell us what the problem is, if the application is suitable for deployment. All right. So DevOps is just basically a philosophy, a way of doing things. All right. Better, a way of doing things more efficiently, a way of doing things more excellently. All right. So that's just basically what DevOps it's about. And if you look at the trend in our days now, a lot of organizations are adopting, all right, DevOps. A lot of companies are trying to make sure that they automate all their processes as much as possible, so that there will not be errors, there will be issues. And the important thing also is that organizations want to, as much as possible, increase how they release updates, right? They want to do frequent, updates. So let's look at a few statistics online. I opened a few websites here to just help us understand this whole thing. So let's look at what these guys have to say. Now, it says that the DevOps market by component, all this information here. So let's start from here. They said the global DevOps market was valued about this and is projected to be, this amount by 2030. So which means there's a lot of potential, right, in the field. Because if they say something is going to grow at a double-digit rate, that means there's a lot of potential, all right, in that field. There's a lot of, there's going to be a lot of openings. Organizations are adopting it. They're adopting the methodology. People are trying to make sure, all right, that they use it as much as possible. Now, if you look at what you have here, it says DevOps works in tandem with agile software development, like we mentioned, and numerous DevOps are derived from the agile approach. It allows for speedier innovation and development by increasing the frequency and tempo of releases. And that is the goal of every organization. They want to release updates as much as possible. All right. So if you look at the global market, it tells you that the DevOps market is growing at a rate of 24.2%, So that tells you that there's a lot of potential. It's not something that is going away anytime soon. All right. So it's something that organizations are adopting, more organizations are adopting it, more organizations are looking towards, DevOps and all of that. And one good thing about it is also that, more countries, where technology is still, penetrating into like Africa and some other places in Asia, there's a lot of potential, all right, for DevOps in those, all right, places. Now, another one here says, let's look at what we have. So another one here says now, as of 2022, 94% of enterprise use cloud services. So which means for DevOps, for cloud engineering and things like that, there's a lot of potential in that field. And it says in 2020 alone, 61% of businesses migrated their workloads to the cloud. All right, so there's a lot of potential, like I said. And if you look at this report that I have here, it says DevOps is now a corporate term. More than half organizations are practicing DevOps, and says over 90% says that DevOps has a direct impact on their business metric. And one thing that is interesting here is this: it says 85 respondent. Now, this is a report by Atlassian. I'm sure it's a popular company. We all know those guys. It's a report by this company. All right, it's a popular company in the space of DevOps. So they are saying they conducted a survey, and this is what they found out. And one of the things that they pointed out here is there's a lack of skill, legacy, infrastructure, and adjusting the corporate culture. So what we are here to do is to get the skill that is needed, all right, for us to be proficient and for us to be able to use these tools, all right, for us to be able to use these processes to help our organizations. And of course, by the time you land your job, you can perfectly fit into any job that you find, and then be able to use all the necessary tools, all right, that DevOps uses. Okay, so that's just DevOps. So it adopts the agile methodology. It's something that helps you to make your process faster. All right, it helps you to ensure that there are no issues and there are no errors. Now, quickly, let's talk about, as a DevOps engineer, all right, what is your day-to-day activity going to look like? What are those things that you're going to be doing? Number one is provisioning and configuring of infrastructure. All right, you're going to be setting up continuous integration and continuous delivery pipelines. You're going to be automating software development processes. Now, automating software development processes, not that you're going to be building softwares. All right, you're just going to help them to build out the infrastructure that needs to run that particular software. And then you monitor the performance of the infrastructure and then of the application as well, to ensure that everything is running as expected. All right, so automation is one of those things that is part of the DevOps process. Now, another thing about DevOps is that the concept of continuous integration and continuous deployment. If you look at this agile model, it talks about, continuous integration. So there's a loop. All right, there's a loop. We get feedback, we go back to a drawing board, we keep developing, we keep pushing new releases, we keep pushing new updates, we keep getting feedback, we keep working on it, we keep pushing out new releases and all those kind of things. And that's why in the production environment, you have the staging area, you have the test area before things go into, all right, the mainstream production, right? And that's why the CI/CD is very important. So let's look at what we have here. All right, continuous integration and continuous deployment. We're trying to define all of these terms so that by the time we get into all these things practically, it will not sound, somehow, right? That's why we're trying to take time to define all of these terms, all right, for us. So that by the time you start doing it practically, and then we're just saying, oh, CI/CD, all these things, you get what we're saying. You're not wondering, oh, okay, what are they trying to say? So that's why we're trying to provide all of this background so that everybody can follow as we go along. So continuous integration and continuous deployment. All right, what does it mean? All right, if you look at the agile methodology, like I said, it's an iterative process. It's a continuous loop, right? You are continuing, you're releasing updates every time. All right, you're doing things every time. You're releasing updates, you're releasing this, and you're releasing that. So there's a pipeline. So basically, you put your code, in a repository. Now, before we even go there, let's try to, simplify this process. Continuous integration, continuous deployment. Now, what does it mean? Let's try to use a simple example, all right, of a factory where they produce, all right, bottled water. Okay, now the factory, obviously, of course, they will have a bottle, they have tanks where, they have their water and all of that. Then that water is going to go through purification processes and all this kind of stuff. Now, continuous integration, what does it mean? Now, if you look at the example of the bottled water, right, they have bottles lined up in different sections, all right, and then they have machines that are positioned that will take those bottles, clean those bottles. Once those bottles are cleaned, it passes them through another process, all right, another process where you now have to fill in those bottles with water. Now, when the bottles are filled with water, it passes through another process again, all right, where the bottles are corked, right? There's the cap is being, put on them, and then it makes sure that, the water is not coming out, all right? And then it moves again from there. It goes into what you call packaging, where they have to label it and all of those kind of things. Now, that is all those processes, right? From putting the bottle to the machine and all that, you can refer to that as continuous integration. So in DevOps, your developers, they are constantly developing. They are constantly improving on their codes. All right. As they're improving on those codes, now one of those things we're going to be looking at in the course of the class is Git. All right. As they're improving on that code, they are pushing new updates to their Git repository. All right. So that is continuous integration. So they are getting reviews, all right, from customers. They're getting feedback from customers. As they're getting those feedbacks, they are pushing back those feedbacks. All right. They are working on those feedbacks, improving on their own code, and then they are pushing those improvements into the Git repository. All right. That is continuous integration. They keep working on it. They keep working on it based on the reviews, based on the customer feedback. All right. Based on what the clients are saying, they keep working on the code. They keep integrating it back into the Git repository. All right. That is continuous integration. Now, once they commit, all right, their new improvements, their new code into the repository, all right, a build job is started. So which means that code, all right, there's a system that takes that new commit and builds up that application for testing. To say, you know what, this developer has committed a new code, but we need to test it to be sure that this code or this new integration is fit for deployment. All right. So the system takes the code, builds it up, and that's where your Jenkins comes in, your GitLab CI/CD comes in. All right, Travel CI, all this Cycle CI, GitHub Actions, all of those guys, they come in that space of CI/CD. So basically, what they do is the developers committed his or her code. All right, the system takes up that code, something triggers the system, it builds that code, all right, into an artifact, all right, something that you can run on any system, right? It builds up as an artifact. We're going to see all those artifact stuff as we move on. It builds it, and then there's what you call unit testing. So basically, it takes, all right, what the person has done, it tests, that portion of the code to see that, okay, is this thing working? Is this everything okay? Is everything fine? Now, if everything is fine, there's the integration process, right? Which means it integrates into the mainstream. Now, the mainstream does not mean it goes directly into the production server automatically. There can be test servers, there can be deployment servers. It integrates into those deployment servers, and then there's a review, all right? Because in a production environment, you don't just commit something to Git and then it's released to the pipeline. No, there has to be somebody that will review what you have committed. So maybe your supervisor or somebody that is above you and all that. The person looks at what you have committed. The person looks at the report, all right, of the testing and of the review that the system has done. And if everything seems fine, if everything seems all right, the person approves, all right, that that new development, and then it goes into the staging area, which is probably the test area, so that the people that are doing quality assurance can check it, can test it, all right, user testing and all those things, and then it goes into production. All right. So just like you produce anything, there are phases, there are levels. If you look at even if you look at cooking too, for example, if you look at the concept of cooking, if you want to cook a meal, for example, all right, you don't just put all the ingredients into the pot all at once, right? There are processes, okay? So for example, for example, in Nigeria, we love jollof rice, right? As Nigerians, we talk about jollof rice a lot, right? If you want to cook that meal, for example, what you do is not to put the rice, the water, the ingredient, and everything at the same time. No, there are processes, right? So the first thing you do is there's your pot, you clean your pot, you put water into it. Maybe the water boils a little, then you put in your rice. Now, putting in that rice is continuous integration, right? So you've integrated rice. Now, you allow the rice to boil for a while. After the rice has boiled for a while, you can, put it, somewhere, take the water away, and then you can, there are different ways to do it. You now get your recipe, put your rice back, start adding the recipe. Now, once you have the recipe and all that, you allow the thing to also cook for a while. Now, before you serve that meal, before you say, oh, this meal is done and all that, you test, all right? You take a spoon and check and say, oh, okay, is the salt enough? Is the Maggi enough? Is this recipe, is it the right content I've put in and all that? You test. Now, if the Maggi is not enough, you do what? You integrate Maggi again. You put in a little Maggi, all right, to check and see, okay. So after a while again, before you serve it, you check again to see, okay, I've added a little Maggi here and there. Let me check again and let me see if this thing is fine for consumption at this level, all right? So if it is fine for consumption, you don't just check for the Maggi, you also check for the texture of the rice. So is this soft enough for somebody to consume? Is it okay enough? I need it to just, still cook or boil a little and all that. So you check that. So all of those things that you are doing while you are cooking is continuous integration. All right, that is just putting it simply, right? Is continuous integration. Now, after you have tested, the rice is soft, the texture is good, the recipe, everything, permeated very well and all that, you're good and all that. Okay? All right, so you've tested it, you've checked it, then you now move on to the level of deploying. All right, that's where you now set the table, you now serve, you put it in the plate, and then you sit down and you start consuming what you have cooked. So that consumption phase, all right, is the deployment phase. Okay, so CI/CD, your developers are working, they're committing their code into the repository. All right, as they are committing the code, the system is building, the system is testing to check for errors and to ensure there are no issues with the code. And after all the errors have been checked, somebody will have to review it and say, okay, fine, everything is good. Or the report from the build phase, everything seems fine. You can commit this thing into production, and then it is released for consumption. All right, so that is continuous integration and continuous deployment. And it's something that is really very important. Now, all these things that we have talked about need tools, right? You need tools to do all those continuous integrations and continuous deployment. Now, remember, the goal is to automate all of these processes. There are not processes that we want to do manually, right? So there are different tools, all right? Just like the cooking example that I gave, all right? If you want to cook, you need different tools to do the cooking, all right? You're not going to boil the rice on your own hands, right? You're not going to put the water in your hands and be boiling it. You need a pot, you need a gas cooker, all right, you need to get your recipe, you need to get your chicken, you need to get so many things, and then you now put all those things together, and then you have a meal, right? So in CI/CD as well, you have different tools that you need to use, all right? So you need to install different tools. For example, you need an IDE. An IDE, for example, can be your Visual Studio Code. It can be things like, PyCharm and all those kind of stuff, all right? So you use all of that to write your script and all those kind of stuff. So there are different tools that you would need. All right, for example, here is a Visual Studio environment. All right, so where you can, now you need, we're going to be showing us how to install this because you're going to need a Visual Studio code to write your Terraform script, to, do your Git and all that. So we're going to be telling us and showing us how to install all of this application, right? So you need all of, you need different tools. So if you look at here, we have, this is Git. I have my Git here, which is integrated. There's the Terraform, all right, integration here. There's Docker integration here. All right, there's some other integrations, GitHub Actions. So there are a lot of integrations right here, so that we're going to be looking at in the course of the class. All right, so you need to install different tools in order to do your job effectively. So let's look at a few of them. All right, for example, you need to install Git on your system. Git has to be installed. It's something that is needed. It's something that you need. All right, you need for monitoring, you need Prometheus, which is the one next to the Git. And then you can have GitLab or GitHub, whichever one the organization is using. Grafana is here to help you visualize, all right, the performance of your system. And then, of course, you must be conversant with at least one cloud provider, which is AWS, and that is the provider that we are going to be using in the course of this class. And then there's Terraform right here, which is for infrastructure as code. All right, remember, the goal is to automate processes as much as possible. All right, you don't want to do anything manually, right? You want to automate all the processes and all of the processes as much as you can. Okay, so Terraform is here. Then the Jenkins is what helps you to do your CI/CD, continuous integration. So your developers are pushing their codes, Jenkins is building it and is deploying it to, all right, on an EC2 server or an EKS server. If you watch some of the videos that we did, the free videos that we did, we looked at Jenkins, how you can use it to deploy stuff to EC2 and all that. So Python here, like I said, initially Python, you're not a software developer. The purpose of Python is to help you to write automation scripts that can automate whatever tasks that you have, within your environment, so that you don't go through any manual process. And one of the beauty of this automation is this. Now, if you are deploying things on the console, let's say you are using AWS, for example. If you deploy all your applications using the console, there's a lot of problems that comes with that. Because if you're dealing with an organization that, they have, they want to deploy the application in different AWS regions, right? So which means if you deployed everything using the console, all right, let's say you deployed in the London region or you deployed in the North Virginia region. So that means if your organization is going to the Asian region, so let's say maybe somewhere in South Korea, for example, so they are using one AWS, all right, they're using another, they have another account, all right, in that region, and then they want to deploy the same application that you have deployed in the North Virginia region, they want to do it there. Now, the problem with that is you have to go there again to the console and start provisioning all over again. That's the problem with, deploying on the console. And that's why this automation thing, it makes a lot of sense, because all you're using is a script, right? All that you're using is what? Is a script, okay? And that same script can be used in any region. So if I deploy something in North Virginia, and I need to deploy the same thing in, let's say, AU West 2, maybe the London region, all I need to do is to take my script, remove or change a few parameters there, like the availability zone and region name, and then I go to my environment, I just run my script, and then I have my infrastructure in just a few minutes. All right, so it helps you. And then another thing that it helps with is also transparency, right? So it helps you to be transparent, so that if anybody should come and want to take over from you, they don't have to go over the console, because there are areas you may not even remember to show them. But if they have a script that you have used, all right, to deploy something, it is easy for them to, all right, to navigate. All right, you can look at the script, study the script, and see, oh, okay, this person deployed this at this time, this person did this one here, and all of that. So it's easy for anybody to follow, okay, compared to having, doing everything on the console and all of that. So that one, it's a lot of issues and a lot of stress. Okay, so that's the advantage of, all this automation that we are talking about. So there's a lot of, error is reduced, all right, it improves productivity, okay, and then there's a lot of transparency, okay. So if anything is happening, you can see it from your script and say, oh, okay, I think my script, there's an error here, okay, line 10, line 15, line 20, and then you're able to correct, all right, all of those errors, right? Now, let me show us an example of what a script looks like, because we're going to be interacting with this. Now, if you can see my screen, you'll see that what you have here is a CloudFormation template, right? This is a CloudFormation template that was used for one of our classes. All right, it's a CloudFormation template. So with this one now, CloudFormation is native to AWS. All right, it's something that only works with AWS, unlike your Terraform that can work with any cloud provider, right? So this is a CloudFormation template. So for example, if I want to deploy this script now is, it was deployed in EUS 2.8. So if I want to deploy all of these things that I have here, let's say in the non-Virginia region or in any place, all I need to do is just to come here and then change this, my region, to non-Virginia region, and I deploy my application and everybody's fine. All right. Unlike, doing everything on the console, and then you want to do it in another region, you start clicking again and clicking. That's a lot of stress, right? Where you can just define everything in a template, and then with the template that you have, you can run it anywhere, right? There's flexibility, there's transparency. Anybody can look at it and know, okay, this is what you have done, this is what what you have used, and all of those kind of things, right? So that's the advantage of all this automation that we are talking about. So your Python is to help you to write all those scripts and all that. Ansible, it also helps you to manage those infrastructure, the configuration management. That's what Ansible does. And one of the core thing about DevOps is the concept of Docker, right? Packaging applications as Docker images, right, in a portable format. And your Docker image can run in any environment, because one of the challenges they had then between the development and operations is everybody will have to install or whatever run. So if somebody is developing in Java, that person has to install all the Java dependencies on their system. Now, the problem with that is if somebody is using a Mac system and somebody is using a Windows system, right, obviously their installation of Java is not going to be the same. All right, because the version of Java that the person using Mac is going to download is going to differ from the version of Java somebody using Windows would download. All right. So there's a lot of issues between the development and operation. So this person says, I've tested it on my system, it worked. This other person says, I'm testing the same thing and I'm getting an error. All right. So Docker solves that for you. So what you now need to do is to just install Docker on your system, whether you're using Mac or Windows. Just install the Docker runtime. Whatever application you have developed as a developer, package it into a Docker image. Give me the Docker image. I have the Docker runtime on my system. I'll run the Docker image on my system, and then everything works. So I don't have to install the Java dependencies on my system. You don't have to install the Java dependencies. All you need is just the Docker runtime, and then whichever platform we're using, all right, the Docker runs, everywhere. And so you now need a system to manage these Docker containers, all of that. And then that's where the Kubernetes comes in, which is this guy right here. So Kubernetes comes in, it's an open source project by Google, all right, and then it's been adopted by different organizations today. So Kubernetes basically helps you to manage all your pods, your Docker containers, and all of that. So in an automated fashion. So that's what it does. So these are the tools, just not all the tools, but these are just some of the tools that you learn in order to be able to do DevOps. Now, all of these tools, we're going to be talking about them independently, but of course, we're going to be working with them and then integrating them one after the other. All right, because all of them, they work together, right? So we're going to be connecting them together, because that's one of the things about DevOps. DevOps is not just about tools, it's about, how these tools integrate together. All right. So DevOps is not just about learning tools, but about integrating them together. So we need to learn how to integrate all those tools together. Okay. How does Jenkins work, with AWS? How does Jenkins work with Kubernetes? How does Git work with Jenkins? How can I monitor my application? All right. And all those kind of stuff. All right. Now, the last thing we want to talk about is cloud computing. So cloud computing basically is just, before cloud computing, what we had was, if an organization wants to develop an application, they have to buy all the servers upfront, right? They have to buy, bulk servers, okay? And then that takes a lot of time. Now, the advantage of cloud computing is that it takes away what you call capital expenditure. So which means you are not buying anything upfront, okay? you're only paying for what you're using. And so there's this concept of operational expenses. So organizations are moving from capital expenditure to operational expenses. Capital expenditure in the sense that if cloud computing was not there, and I have an application I want to run in-house, that means we'll have to buy servers, all right? We have to have different teams. So server engineers, all right, network engineers, you have to set up the infrastructure, you have to set up cooling, you have to set up a lot of things, all right, yourself. You have to guard against natural disaster. You have to also ensure that you have power running 24/7 and all this kind of stuff. And so all this, organizations, now they have taken away all of that stress. They abstracted all of that to say, you know what, we are going to make the investment. We're going to buy the servers, all the servers that you need, we're going to buy it, we're going to install it. All we're going to do is to provide you with a platform where you can come, all right, rent these servers, and then you pay on an hourly basis. All right, so which means you don't need an investment of $20,000. You don't need an investment of $10,000. You don't even need an investment of $1,000, right? You can start as little, all right, as 10 cents per hour. All right, so that's what the cloud provider does. That's what they've done, and that has helped organizations greatly. All right, and that's why you have a lot of startups now. Sometimes you wonder, all these startups, today you hear this startup has come up, somebody has come with a company again, another startup here and there. And most of this startup, the interesting thing is they don't even have a physical office, right? They don't even have a physical office or a physical location. So the question is, so that software that they are promoting, that fintech application that you have on your phone that you're using, so where is it hosted if they don't have an office? The answer is simple, it's hosted on the cloud. And when you're working on the cloud also, you don't need the physical location. Everybody, they have their laptop, they have internet access, they can work from anywhere on the application, they can do whatever they want to do. They don't need to be in a physical space. And that's why during the COVID-19, pandemic, everybody people were able to stay in their house and they were able to work. And then there was a lot of tools that was developed, all right, during that time. Okay, so cloud computing gives us that, leverage. So if you have an idea now, for example, maybe you have a fintech idea to say, okay, I think I have a way where people can, do this transaction and do that transaction, with their mobile phones and all that. You don't need to go and rent an office, all right? You don't need to go and rent a server. You don't need to go and, invest so much in infrastructure. All you need is just sign up on AWS, put in your credit card details, get a server that you can use, provision your application on that server, make it public, let everybody start accessing it, and you're good to go. So cloud computing takes a lot of that headache, all right, from you. So it takes away the capital expenditure. You can imagine somebody who has an idea, the person does not even have $1,000 to spend, and then cloud computing is not there. That means that idea is going to die. That idea is not going to fly, because people will not, it's rare for people to invest in you when they've not even seen what you've done. All right. But with cloud computing, you don't need anybody to loan you money at first. You can start small and then show them what you're able to build out. And then you can now seek for their funds to say, you know what, if you want this application to scale, then we need funds, right, in order to get bigger servers, all right, bigger systems that can help us to deliver this application. So these three major providers, AWS, Azure, and GCP, what they are basically doing is they still have the data centers all over the place, all right? They have servers, thousands and millions of servers all over the place in different countries, in different regions. And so what they are just providing is to say, you know what, you don't have to spend that money, all right? You can start so little, and then you can scale as your organization grows. All right, you can scale as your organization grows. So let's log in into AWS. Let's see just a few things. That's the platform that we're going to be using, all right, in the course of the class. All right, that's the application that we're going to be using. So do I remember? Let's see if I can remember. So that's, what those guys have provided us with, and it's a lot of benefits, right? And like we saw in one of these reports, let me see, where's that report again? Like we saw in this report, it says in 2020 alone, 80% of businesses move their workloads to the cloud. And it says something here. It says, and there's a reason why. It says, as the cloud comes with many benefits, from cost cutting to data security. And it says, in fact, 80% of companies report operation improvement after adopting the cloud, right? 80% of companies, that's huge, right? That's really huge. 80% of companies, all right, reported, all right, improvement in their operations after adopting the cloud. And it gives us a very wonderful report here. It says, impressive growth like this has caused the global cloud and global cloud computing market to reach a $480 billion, all right, and with expected gains in the coming year, and then is expected to grow by 16.3% through 2026, and then they're expecting a growth of almost, $1 trillion. So there's a lot of potential, right, in the cloud computing space, and that's why the skill is needed at this time. All right, people need to learn it, people need to know it, because most organizations are moving their workloads and they need experts, people that can help them to build, to manage, to implement, all right, all of this infrastructure. Okay, and that's what this guy simply provides. All right, so let's log in into this one. Let's see, for the benefit of those who may not. So you have to create an account. That's the first thing that you have to do. All right, you have to create an AWS. I'm going to send a link to us so that for those who don't have an account yet on AWS, you can create your own account. All right, and then you can sign up so that we can, because we're going to be deploying a Linux server on AWS, and I'm going to show us how you can do that. We're going to be using a few AWS application to deploy our Linux server. All right, so if you don't have an account yet, you can go to, I think, if you go to AWS, I think, let me see, Amazon.com, AWS and Amazon.com, I think /free, that's correct. All right, so if you go to this website, you can create an account on AWS. Yes. So you can create an account from there. All right, so yes, to answer that question, somebody with no IT background can do well, right? Everything that we know, we started somewhere, right? And that's why we are providing all of this background. That's why we are providing all these details that we are providing. That's why we are taking our time to explain all of this concept, all right, so that people can follow and understand. So there's nothing that you know today that you didn't have to start from somewhere, right? You started from somewhere, and then gradually you became an authority in that area. Right, so even if you are moving newly to the cloud space, all right, or to DevOps and all that, you have to start from somewhere. And that's why we are not rushing anything. We're starting from the basics, and then we're going to take it, from the basics up to the advanced level. So what you need basically, it's your own willingness to sit down, review the teachings, review the videos, ask questions when necessary, practice as much as you can, all right, and then if you have any questions, of course, we'll attend to those questions. So it's something that I believe anybody can do. It only takes time, right? You just have to stay with it, learn it, and you're right, get familiar with all the concepts. And that's why we're starting from all these explanations, the theoretical explanations, all right, that we're trying to do. Okay, so you can create an account here. So if you click on the free account, it takes you to where you can create your own. So you can sign up from here. All right, it's going to ask for your credit card details. And then I think they debit around $1 or so. All right, on your credit card, they debit around $1 on a credit card. So just to test and to be sure that, if you incur any charge, there's a way they can get their money and all that. Okay. So just go to the site. If you don't have an account already, open an account. We're going to be using AWS a lot. We're going to be using a lot of their services and stuff like that. So let me see if I can log in into my own platform. I just want to show something real quick. It's asking for MFA. Don't worry about the MFA. We'll talk about MFA, just a form of authentication. All right. If you're familiar, if you're using Gmail and all these other email providers as well, all right, you have a form of authentication that you also use, right? For example, if you want to log in into your Gmail from another system, it sends a notification to your mobile phone that, are you sure you are the person? If you're sure you're the person, it asks you to press yes. And at some time, it displays a number for you. It displays 3 numbers. And then on your system, it displays just 1 number. And then on the phone, you have 3 numbers, and it expects you to choose, all right, the one that is correct. So the MFA is just a form of authentication to ensure that you're actually the real person trying to log in. All right. So we're going to be using AWS. In the next class, we'll talk about there's something that we have skipped, which is IP addressing. So in the next class on Wednesday, we're going to talk about IP addressing. All right. What is IP addressing? How do what are those things you need to know about it? We'll talk about CIDR, we'll talk about subnet and stuff. All right, like that. So we talk about all that. Then we're going to be looking at EC2 as well, just how you can create, all right, a system in order for us to start, learning Linux. And possibly also, there's an AWS service that is called Cloud9, which helps you to, like the Virtual Studio Code that I showed us earlier, your Cloud9 provides you that same environment in addition to a Linux environment so that you can interact. So that for those who may not have, Linux on their system or who may find it difficult to install it, all right, you can use a combination of Cloud9 and, all right, this Linux environment and do the practice as we are going to be doing it in the class. All right, so we're going to be showing us that on Wednesday or the next time that we're going to be meeting. So we're going to be delving into, after the IP addressing, we delve into Linux straight away. So we need to start practicing Linux and see how Linux works, because basically Linux is the operating system of the cloud. So if you want to do well as a cloud engineer in the IT space generally, right, you need to have an understanding of Linux. All right, you need to have an understanding of Linux. Now, all these things are not difficult. Like I said, everything that we learned today, we started from somewhere. All right, so don't see it as something difficult. Don't see it as something that is hard, right? It's not hard, because, for example, for somebody like me, if you look at some of the guys that are doing well, right, in the world today, let's take Elon Musk as an example. All right, the guys, he has a company called SpaceX, which I'm sure most of us know about. And then they did a test, I think last month or something, there are rockets that they wanted to launch into the space. I think the biggest rocket in the world for now. All right. And the thing blew, midway, the thing blew off and all of that. And they lost about $3 billion, right? That's a huge amount of money. But the guy congratulated his team. It was okay. He was fine with it. That's a tough one. All right. It's something that's difficult. $3 billion just blown away like that. It's difficult, right? But of course, they are back to the drawing board. And according to him, in a few months' time, they're coming back for another kind of test. All right. And now it doesn't mean that that test is also going to be successful. But of course, they're not going to relent until, right, they get to a point where, right, other nations begins to say, oh, SpaceX, we want you to come to our country to help us with this. And then all the money has lost. Before it was happening, we get all those money back, right? So that's the idea. So you don't get tired. So it may seem difficult at first, but you have to persist. All right, that's just the idea. You persist, you keep trying and trying and trying. And that's why we're trying to also build out a community where if you have any issues, if you tried everything that you know to try, you can ask somebody within the Slack space a question. And then, of course, somebody will respond definitely to all those questions. So it's not difficult. It's not something that is not possible. It is possible. It depends on how much you're willing to give to it. And then you can get a result that you want at the end of the day. All right, so that is what we have for us today. So I'm going to show us how we can use the Cloud9 and the EC2 to do our Linux test. All right, on the next time that we're going to be meeting. So now let's give room for questions and contributions. Questions and contributions. So we're trying to keep the class short so that it doesn't look so boring for people. And then people, if you want to rewatch the video, you can rewatch it at any time. So any questions, any contributions? I think the chat and the Q&A is open. So if you have your questions and contributions, please let's have them and we'll respond to them right now. Questions and contributions about what we have said so far. So the next time we're meeting, we're going into the practical straight away. All right. So it's going to be practical. So lineups is what we're going to be looking at next. Do we have any questions? Any questions? Any questions? I'm trying to, please don't leave yet. I'm trying to set up a poll. I want to get information about the time because I'm sure some people are connecting from different time zones. Not everybody's in the US. Some are connecting maybe from Nigeria here and there. You know, I think we have a few Indian guys who are also interested. And so the time zone, it's a bit, it looks somehow. Okay, let me unmute us. So if you want to talk, I think you're muted. Let me just stop the